So our today's topic is digital systems and binary numbers. So in this chapter, we are going to discuss about digital systems, binary numbers, number-based conversions, octal and hexadecimal numbers, complements, signed binary numbers, binary codes, binary storage and register, binary logic. Okay, first one is the introduction. So in the digital circuit and digital techniques, we used almost all areas of our life. So some digital circuits and digital techniques are computers, automation, robots. We used these digital circuit, digital techniques in the field of medical science and technology, transportation, telecommunication, entertainment, space exploration, and so on in our daily life. So there are in the we are in the digital age and information age. There are a lot of digital computers as general purpose computers, many scientific, industrial, and commercial application purpose computers. So some example of digital systems are telephone switching exchange system, digital camera, digital TV, electronic calculators, EDAs, etc. So in this slide, we discuss about analog system and digital system. Analog system is the physical quantities or signals may vary continuously over a specified range. So here this is analog signal. Here it is continuously vary over a specified range. That's why this is a analog signal or analog in the analog system we will found this analog signal. In the digital signal, the physical quantities or signals can assume only discrete values and it has greater accuracies. So this is one kind of example of digital signal. So there are some differences between analog representation and digital representation. One of those is quantity is represented by a continuously variable proportional indicator. So in the analog representation, we do not find any fixed value. So a quantity is represented by a continuously variable proportion. Okay, variable proportional indicator. That means we cannot say the value of this exactly. This is a speedometer. We see this speedometer in the car or in the bus or any transportation we used in our daily life. This is a mercury thermometer. We also see this. We cannot tell exactly what is the temperature by indicating when we see. But in the digital representation, the quantities are represented not by continuously variable, but by symbols called digit. Here, this is a digital thermometer. So thermometer can mercury thermometer is an example of analog representation, and the digital thermometer is example of digital representation. So here we see that 36.8. This is fixed. This value is fixed. This is not analog representation, and this is also a digital clock. Digital clock also have exact value. Uh, Here 12.00. So in case of clock, there may be analog clock also in our wall clock. Wall clock can be analog and it can be digital clock also. There are some differences that in the digital system, combinations of devices designed to manipulate logical information or physical quantities that are represented in digital form. And in the analog system, it contains devices that manipulate physical quantities that are represented in analog form. So digital computer and telephone system are the example of digital system. And besides audio amplifier, magnetic tape recording, those are the examples of analog system. So in the binary digital signal, an information variable represented by physical quantity. For the digital system, the digital signal has only two value, which one is a 0 and 1. And if we represent it in words, we can say it is 0 as false and 1 as true. Otherwise, 0 as low or 1 as high. Otherwise, 0 as on and 1 as on and 0 as off. So binary values are represented by values or range of values of physical quantities. So here we see that this is our logic 1 and this is our logic 0. But this is our logic 0 and this is our logic 1. Here this is logic 1, this is logic 0. But this period, transition period from 1 to 0, or the transition period of 0 to 1 is known as undefined. So this is undefined region. So which of these quantities are analog and which are digital? Suppose number of hair of your head, so it can be digital. Setting time for microwave oven, it is digital. Radio volume control, uh, it's analog. Atmospheric pressure, this is also analog. Number of atoms in a sample material, it can be count, so it is a digital one. And automobile fuel gauge, it also analog if it is a needle type. Temperature of a noob, it is also analog. And the current flowing from an electrical outlet is also an analog system, example of analog system. So there are some assignments you can do for your study purposes. First one is the listed some digital systems and analog systems, advantage of digital techniques, limitations of digital techniques. So now we are going to start about our number system. There are four number systems we are going to discuss. First one is decimal, which one is base 10, binary, this is base 2, octal, this is base 8, and hexadecimal, this is base 16. So in the in the decimal number system, the base of this number system is only 10 digits. What are those 10 digits? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Similarly, binary is based on only two digits, which one is 0 and 1. Octal is based on a digit, which one is 0, 1, 2, 3, 4, 5, 6, 7. Hexadecimal have 16 digits, which one is from 0 to 9 and A to F. Those are the number systems. So we see that in every number system, there are some base digits. Depend on those base digits, numbers are formed in the number system. So here we see that in the base 10 number system, 0 to 9, in the base number system, if we see here, 0 to 9 is repeated in every 10 times. Okay, are here 0 and 1 both are repeated in every 2 times. Similarly, in basic 0 to 7 is repeated in every 8 times, and 0 to F is repeated in every 16 times. So, what and how we will edit two numbers in different number system? Here, actually, we know very well the addition of decimal number system because we are using decimal number system addition in our daily life. But computer uses binary number system, and it also uses hexadecimal and octal number systems. Hexadecimal and octal number systems are two different form of actually binary. Okay, so computer actually uses binary, octal, and hexadecimal number system. So here, the addition of 25 is a decimal number, 37 is a decimal number. So if we add 7 plus 5, that means 12 2, and 1 in hand. So 3 to 5, 5 plus 1 is equal to 6. But in case of 25, 16, 25 can be a hexadecimal number also. 37 also can be a hexadecimal number. This is also correct. But in case of hexadecimal number system, so what will be the result of addition of 25 plus 37? So 7 plus 5 is equal to 12 in the decimal number system. So you have to convert these 12 into hexadecimal number system. For that reason, just divide 12 by 16. So you will get, if you divide 12 by 16, you will get 12 as a remainder. 12 as a remainder. So 12 means in the hexadecimal number system, there is actually no digit of 12, but there is a digit which represents 12, that is C. How? Suppose in the hexadecimal number system, first there are 16 digits actually. What are the digits? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C. So if you see D, E, and F, these 16 number, if you see that C is in 12th position, so 7 plus 5 is equal to 12 in the hexadecimal number system, and 12 represents actually C. That's why the result is C here. So there is no carry actually, and 3 to 5. 5 is also, if you divide 5 by 16, you will get 5 as remainder. So there is a digit 5 in the hexadecimal number system. Just put down this 5 here. So if you add 25 and 37, which one is a hexadecimal number system, you will get 5C in the hexadecimal number system. But again, similarly, 25 and 37 both are also can be a octal number also. Because these 2 and 5, those digits are belongs to octal number system. 3 and 7 is also belongs to octal number system. So 25, 37 both can be a number of octal number system. So what will be the result if we add 25 and 37? So 7 plus 5, if we add it in decimal number system, 7 plus 5 is equal to 12. There is no doubt. So please divide these 12 by 8. Okay. If you divide 12 by 8, you will get uh, 4 as a remainder and 1 as a dividend. Okay, so just put down these 4 here. 7 plus 5 is equal to 12. Just divide 12 by 8. So you will get 4 as remainder and 1 as dividend result. So just put down the remainder here, 4. Okay, 4 is here and the dividend result 1 will count as carry. Okay, just add carry with 2. That means 2 plus 1. That means 3. Then add this 3. So 3 plus 3 is equal to 6. So very easy. So we see that if 25 belongs to decimal number system, hexadecimal number system, octal number system, and 37 also can be as part of decimal number system, hexadecimal number system, and octal number system. So if we add those two numbers in decimal number system, we get the result 62, but we get 5C when we add them in the hexadecimal number system, and then we will get 64 as a result when we add them in the octal number system. So hopefully, I think you will understand about addition of two numbers. So now I start number-based conversions in the binary number system. There is 2 digits 0, 1. Octal number system there is 8 digits 0, 1, 2, 3, 4, 5, 6, 7. In decimal number system, there is 10 digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And hexadecimal number system, there are 16 digits 0 to 9 and add to F. So we actually I categorize these base conversion into 4 categories. First one is the decimal to any base. Second one is the any base to decimal. Third one is the binary to octal and vice versa. And fourth one is the binary to hexadecimal and vice versa. First of all, we will discuss about decimal to any base conversion. There is a decimal to any base conversion. So in a decimal number, there can be two parts. One is the integer part and another is the fraction part. So in a number, there can be two parts, integer part and fraction. So if you want to convert decimal to any number system, at times you have to divide the integer part of the number by the uh, base where you want to convert. That means here we are going to convert decimal to binary. So here integer portion is 10. So you need to divide 10 divided by 2 and divided by 2. Okay. If then the fraction part will multiply by the converted base, that you want to convert actually. So here 0.25 is multiplied by 2. So here at first we see the division portion, 10 divided by 2. So here 5 is the dividend result and 0 is the remainder. Then again 5 divided by 2, 2 is the dividend result and 1 is the remainder. Again 2 divided by 2, 1 is the dividend result. Sorry, right. 1 is the dividend result and uh, remainder is 0. Again, if we divide 1 by 2, so 0 is the dividend result and 1 is the remainder. So when you will get 0 as a dividend result, you should stop the division. Now, in case of multiplication of fraction part of the number, you should multiply always the fraction part. Remember it. So here 0.25 into 2, you will get equal to 0.50. Now you should multiply 0.50 by 2. So you will get 1.00. When you see the fraction part is full of zeros, that times you should stop the multiplication also. So after completion of conversion, we will get the result. So just count the remainder here from bottom to up. Okay, that means 1010. And here count the integer portion. Count the all integer portion from top to bottom. That means 0, 1. So you will find the converted binary number of 10.25 from decimal is 1010.0. Okay, 1010.01. That is the case actually. Now, if you convert this decimal to octal, similarly, just divide 10 by the base of octal, that means 8. So if you divide 10 by 8, you will get 1 as the dividend result and 2 as a remainder result. Now again divide 1 by 8, you will get 0 as dividend result, 1 as remainder result. So that means the converted value of 10 is 1, 2. And now 0.25, the fraction part will multiply by 8, you will get 2.00. Okay. Since you get all of the zeros in the fraction portion, so you should stop the multiplication right here. Now the converted value of 10.25 is 1, 2. You should count from bottom to top the remainder and the integer part from the multiplication result from top to bottom. Remind it. Okay. So the converted value of 10.25 in decimal number to octal number is 12.2. So I hope you can understand how it works, the decimal to octal conversion, decimal to binary conversion. Similarly, uh, if you want to convert the decimal to hexadecimal number system or decimal to base 3 or decimal to base 5, that times if you want the integer portion will divide it by base 16, base 3 or base 8 or base 5, and the fraction portion will be multiplied by base 16, 3 or base 8 or base 6. That is the case.